Determine the reactions at roller support A, the ball and socket joint D, and the tension in the cable BC. So let's see what reactions we have here. First we have a reaction at A. So this is just going to have A in the Z direction. It's allowed to roll in the X or Y direction. At D, we're going to have a D in the Z direction, but it also restrains it in the D in the Y direction, and it restrains it in D in the X direction. At C, all the rope can do is pull up, so we have C in the Z direction. So let's start by summing the moments at D about the x-axis. So if I cause the rotation about the x at the point D. So sum the moments at D about the x-axis. All the D reactions don't matter because they all go through point D. So we're looking at the 600 Newton force, and it's acting down, so it'll cause rotation in the positive x direction, and the distance there is 0.3. And then we have the CZ up, so and that's going to cause rotation in the negative x. And the distance there is 0.8. And then we have the 900 down causing positive rotation. And the distance there, that is in 1, so I think the distance there is 0.7. And then we have AZ up. And that also is 0.8. It's on the very edge. Cleaning that up, we have 0.8 CZ plus 0.8 AZ equals 810. Now let's sum the moments about B. In the y direction. So if I sum the moments about B in the y direction, or on the BD axis, right, I got 600 times that length, 0.2, plus 900 times that length, 0.6, times AZ times that length, which is 1. So solving that directly for AZ, we get 660 newtons. Putting it into there, we get 0.8 CZ plus 0.8 times 660 equals 810, and CZ is equal to 353. Finally, we'll sum the forces in the Z direction. There's 900 down, 600 down. There's AZ up, CZ up, and DZ up. They all equal 0. We know what AZ is, we know what CZ is, putting in there, solving DZ is equal to 487. The remainder, we got a D in the Y, we got D in the X. There are no X or Y forces, so therefore D in the X is equal to d in the y is equal to 0.